hit this lightly, but enough. So hopefully we do a good job with this. Looks strange. It says find inverse cosine of cosine of pi over 5. Who can tell me where am I headed? Nima.
This is following the rule that says f o f inverse, which is x. So in this example, it's gonna be pi over 5.
You know what, Professor, we saw is exactly what he's telling me. Exactly right. He said, Professor, if you do that on inverse composed with the original function. And I think you guys did one of these on your last exam. I asked you to do it like a check, and you're supposed to get what? X. He's telling me, Professor, that's exactly what this is doing here. That's exactly what that in the black there is doing. It's making use of that property. So the answer should be, Neva, tell what the answer should be.
Pi.
Fine. You're done. I think in terms of what inverse cosine, which cosine does for me. I'll try another one here with you. Neva, since you helped me so much on that one, let's try another one here. Part B. And I brought this one in, so it's easier to where I want to go. This one says sine of inverse sine 1/4. May I apply the same thing Nima gave me as a rule to follow? Can I use the same rule here? And say, Professor, what? This is the easiest part of it's ever. Is the answer merely 1/4? Or you're doing like what? F of the inverse of x, and you're supposed to get x, as we've seen in class before. And you say, wait, Professor, the x is that, so that should be the answer. You guys agree? If I follow the rules. So, Jonathan, this comes down to an inverse cosine with its cosine, inverse sine with its sine. If you do a composite, you should get x. Just like you did a check on that last exam, I think you guys had a logarithm or something. Check for me. Had a check. That's what we're doing. Yes?
But it still has to fall within the.
There you go. You're perfectly said. You're saying, Professor, you gotta be careful though, if you go outside what I was talking about before the break, the restrictions, you can't do it. Okay, so if I go outside the restriction, you just put undefined, it's not defined, or maybe something else has to be done to it. But these right here, I think, guys, look pretty good, don't they? Now, why did I bring these two in? I want to now, why not? I thought about this. Let's visualize what this means. This means there's an angle out there whose sine is 1/4. It's not one of those on the inner circle. But that's what this means right here. There's an angle out there whose sine is 1/4. Right like this. Comma. And the inverse notation tells me before the break, the restricted interval to find that angle has got to be located between negative pi over 2 and positive pi over 2. That's what this is. That's for inverse sine. I talked about that before the break. That's its restriction. So the angle I'm looking for falls between negative 90 and a positive 90. Barbara, there's no way, I don't know what the angle is. 1/4 is not on that unit circle, but there's an angle out there. Mr. Parks will shortly tell me what it is. I don't know what it is myself. But there's an angle out there whose sine is 1/4. All I know is it falls between these two. Now guys, in terms of quadrants, let's visualize what's going on here. If I say it falls between these two, here's another way to think of it. Am I saying, as I look at this, let me label this as negative pi over 2. This is pi over 2. Are we saying the angle I'm looking for must fall either in quadrant 1 or quadrant 4? If you're caught between negative pi over 2 and positive pi over 2, are you either here or in quadrant 4? Are those two locations? A closer look, I gave sine as a positive 1/4. Is sine positive in quadrant 1, or is sine positive in quadrant 4? 1. I think sine y is negative down in quadrant 4. And now I know this much. My angle is in quadrant 1. That's all that thought. I still don't know the size of it. I'm not going to ask Mr. Park yet. If I know what I can do, I can still find the answer to this without the knowledge of the size of the angle. The angle is called between 0 and 90. It could be 22 degrees. I don't know what it is. But I can do this much to it. As we stretch this out and make it larger so you can see it. Here's the angle. And stretch this out so you can see it. Like that. And I'm going to drop a perpendicular down to the axis and form a small right triangle. Go to a visual. I have no idea what size angle we're dealing with. So theta is going to be placed right here. What do I know about it? Its sine is 1/4. And by definition, sine for us right now is y. Isn't it just y for us for the unit circle? So it says the y, which is the red one, is 1/4. As long as I'm talking about the unit circle, which means the hypotenuse is 1. Remember this, drawing the hypotenuse? So the hypotenuse is acting as the radius of the unit circle. The y is 1/4, and that's what sine's definition is. Sine is y. Now I can easily find the base of the triangle, Jonathan. To find the base of the triangle, I can use quickly what? Pythagorean theorem. To just find the length of the base. Can I find it this way? C squared is equal to a squared plus b squared. Where C in this case, hypotenuse is 1, 1 squared is equal to, let's call this missing, and the other is 1/4 squared. Pythagorean theorem. Or 1 is equal to a squared plus 1/16. Move that 1/16 over, make it 15/16. I'm just doing some math, guys. A squared, take the square root. It's going to be a radical 15/4. If I did the math correctly. Is it true? Where's that go? That's right here. That's square root 15/4. Do I now have the lengths of all three of those sides of that triangle? Now, sine is equal to 1/4. I've got it labeled. I've got the angle. I've got everything I need there. So far, so good. I've got it labeled correctly. Now, I think the way to do this. Mr. Park. Need a little help here. We got a visual one now. Would you go ahead and find, use your inverse sine key. Find sine, inverse sine of 0.25 or 1/4 and see what it shows for the size of the angle.
It gives 14.47.
14.47?
Yeah, degrees.
Stop there. I would never guess it's 14.47 degrees. Not only that means that this angle I have marked right here now has a measure of 14.47. Have you ever seen a 14.47 on the unit circle? You never will. And they came and said, Ramsey, what's the size of the angle? I'll lose my job. I didn't know it was 14.47. I don't think anyone else does until you turn to a calculator. But that's the size of the angle. Now, Farbod, you said, Professor, the visual makes sense. You set it up for us, and so forth and so on. Now look what it says to do. It says take sine of that. What is sine? Is that y? Please tell me, does that y, even on the sketch, is that y 1/4? Does that sure enough take me right back to the answer that we thought it should? Do they match up? Again, just a little justification that they should match up on that inverse. Is that true? Done. Now, letter C. This is where the fun's gonna start coming in. I'd like to find now, with your help, here we go. Secant of, oh boy, hang on, oh yeah. Secant, inverse tan, 4. Now we got issues. We got issues. What's the issue? What's my issue? Why can I not give a direct answer, Miriam? Like you guys told me quickly, Professor, I think on this one, with this, is that answer.
Secant is not the inverse of.
Thank you, I got 2 different functions going on here. I can't do it. I can't just say the answer is 4, I wish I could. No, these do not match up. I need big time help. Big time help. I see 2 different options here. I've been waiting for this. I think this is going to explain more in terms of you guys who have been a little confused about all this. It's going to make more sense than ever. First, let me translate this. This says there's an angle out there whose tangent is 4. That's what it means. Just the inside part. And since they gave me inverse tan, that angle is located where? Between negative pi over 2 and positive pi over 2. Yes or no? Now, Aiden, if I ask anyone in class to tell me the size of that angle, whose tan is 4, and say, you are dismissed, I'm gonna place an A on the transcript for you, go home, the next 2 weeks is free for you, no final exam, you're done. No one's gonna answer that. So when it came to the door, it said, Ramsey, inverse tan of 4, your job depends on Ramsey. Ramsey's gone. You just don't walk around, no, I don't know that. Inverse tan 4, I don't know what it is. I'm gonna ask Mr. Park to justify or check this for us. Justify for us later on. Right now though, that's all we know. I don't know the size of the angle. Now, does this mean the angle though does fall between quadrant 1 and quadrant 4? Somewhere in quadrant 1, quadrant 4. I like quadrants myself. So this restriction says the angle is either here or here. I gave you tan is 4. That's a positive 4. I think if you go down to quadrant 4 and put y over x, you get a what? Negative. So quadrant 4 is out. Quadrant 1 is the only one left. So my angle is up here. Let me do it like this. In quadrant 1. I'm going to draw a perpendicular. Form a small right triangle. That's all I know right now. It's in quadrant 1. Its size, I have no idea until I ask Mr. Park. What do I know? I know the tangent should be 4. Now tangent for us is y over x. Can anyone tell me, knowing y over x, how can you label this? Tell me.
If like one is A, the other one's 4A, A2 plus 16.
Oh, I got you. So you're saying y over x, Professor, this is your y, and down here I'll put in black since I have black down here. This is the x, so put 4 over 1, is that tangent? Is that placing y over x? If I place 4 over 1, would that give me 4 like tangent should be? Y over x? This is representing the y, isn't it? Is this the x? So visually, is that tangent? The only trouble, Miriam, if I go through c squared is equal to a squared plus b squared, find this hypotenuse, which is the radius of that circle that goes around there, I think we'll end up with radical 17. Oh, watch carefully, I've been waiting for this. Is it radical 17? Why not? Whoa. Hey, go for it.
Well, we know that sine and cosine only y and x by root 17, doesn't that give us the tangent?
We could, I see what, I follow you. Hang on just a second, we'll go through this first. Okay. You guys agree right now that I do have y over x, that's y, that's x, that's 4, that's what tangent is, it's y over x. And then c squared is equal to a squared plus b squared, I did it quick, but I think we ended up with radical 17. But we're accustomed to what for that hypotenuse or that radius? 1. We always work with the unit circle, so I can quickly change it to a 1. Watch what's gonna happen, this is cute. If I go through and do this, which is valid as long as I do it on all these, I'm gonna divide all those numbers by radical 17. Now that makes the hypotenuse 1, which makes it now a unit circle. If I should draw the circle, I now have a radius of 1. Make sense? Now, what do they ask me to find? Secant. Anyone recall what the definition for secant was?
1 over cosine.
1, thank you. 1 for cosine. Back up, or 1 over x, if you wish. Now refer to my sketch. Let's place 1 over x. That would be on the unit circle, 1 over, and guys, what's acting as the x? 1 over radical 17. Clean that up. Look at this. Now, you're talking about cute. Someone walked through the door and said, Ramsey, you may not know the angle, until Mr. Park gets it to you, you may not know the angle whose tan is 4. But I know, guess what I just found out? Guess what I do know? Tell me what that radical 17 over there, if someone walked through the door, what's that radical 17 representing? Even though I have no idea what size angle it is. What's the radical 17 representing? The secant of the angle. I have no clue what the angle is. That's the secant of the unknown angle. He's going to check all this for me. Done. Now, me as an instructor, and you move it on into calculus. Let's get the screen marker will work for me. Of course, it's not going to work for me when I need it. Option number 2. No triangle. Let's do this. Secant and tan. Can anyone tell me one of the identities that might connect, this is an alternative to get the answer, that might connect the trig function secant with the trig function tangent? You remember sine squared plus cosine squared is equal to 1? You remember all those trig functions? I think you had to use some of those on the last problem of the test. Does anyone recall one that may directly connect secant with tan? I'm hearing it. What was it? Tangent squared. Gotta know your identities. Plus 1 is equal to secant squared. Or about it. I've been waiting for this. I've been waiting for this. This, we know what tan is. Tan is 4. Well, let's just put a 4 in there. I think 4 squared plus 1, that's 17. And if they want secant, I got secant squared. You usually do what? Square root? Do a square root. You end up with radical 17 is equal to secant. Please tell me, is that the same answer we got through the visual for the triangles? You talking about connection. You see a connection. Aiden, when you see one of these and it looks horrible, looks impossible, you can either set up visually with triangles and go for it, or in your mind you can say, oh, I think there's an identity I can use, and go through it. Mr. Park, do me a favor. Here we go. I'd like to know what the size of the angle is myself. Would you find inverse tan of 4 and see what size is that angle? And we think it should be in quadrant 1.
76 degrees.
How much?
76.
76.
Yes.
I would have never known that. Nor would you. No. I think walk in the math department, any math department, go to Stanford. And ask a professor there, a math professor, what's the inverse tan of 4? Unless those professors are way out there. Okay. 76 degrees now. Mr. Park, can you take directly secant of it, or find secant of that angle for me?
Secant 4.
Yeah, secant of 76 degrees.
4.13.
4.16?
13.
13?
Yeah.
We got this answer. Now find square root 17, just mere square root 17.
Um, 4.123.
Okay, close enough?
Yeah.
Aiden, I had no clue, you had no clue. We were clueless. I had no idea that angle was 76 degrees. Jonathan, don't tell me you knew that 76
Oh,
degrees.
no.
Oh, okay.
Question is, are we now stepping away from the unit circle, so the radius
Yeah,
is no
but
longer
if you
one?
step away from it, you can go back to it. Look at on this one right here, I modified, where was it? Oh, I modified this to change it back into a unit circle. So I can take it back to a unit circle so I can use these definitions we're so accustomed to for the unit circle. I just took it back. You can do that. Wasn't that cute? I think, now if I leave it up to you, Miriam, I've had some students, I'll leave it up to you. Some students love this, they're more of a visual type person, I am myself. They prefer to do this business and find the answer. Some students say, no, professor, I want to connect it to identities. You get the answer. Either one's gonna work. Either one's gonna work. I'm gonna try one more here, I have one for you to try. We got one more here, guys, here we go. Letter D. Looks like this. Hang on. Yes, inverse cosine. Oh, here it goes. Tan of, that's what it was. Tan of inverse cosine. And inverse cosine of -1/3. Now this may take a little time. I see students looking at it saying, Professor, this is looking more like an advanced Stanford, USC, UCLA class. Now, don't ask me, because I have no clue. If there's an angle out there whose cosine is -1/3. It's not one of those on the unit circle. I have no clue, but this does mean cosine theta is equal to a -1/3, and the restriction for inverse cosine, the angle is located between, guys, help me out, I think it's between 0 and pi. Yes or no? Barbara, if you know that answer, we're finished. You can go to the beach, and the rest of us will stay here and do the final exam and do everything else. Do you know what angle is between 0 and 180, and the cosine is negative 1/3?
Halves are applies, halves.
Oh, no, I want the answer. What's the angle? No. I'm putting you on the spot there. We don't know. Does it exist? It does. Aiden, I don't know. But they're asking us to do this to it. Find the tan of it. Or maybe I can find the tan of it, even though it's unknown. Now, would you like for this to be set up? I'm gonna set it up both ways, and we'll close this down with this. I'm gonna set it up with, let's do triangles first. Jonathan, you ask about this. Let's translate what we have here. And if you prefer to use, see if I can go in here. Oh boy, the inverse cosine is negative 1/3. Recall between 0 and pi. Oh, by the way, if I call between 0 and pi, that means I'm either in quadrant 1 or quadrant 2. Is that true, guys? From 0 to pi, here's 0. Here's pi over here. So I call between 1 and 2. Now I gotta decide which is it. Is it 1 or 2? Miriam, help me out. Is it quadrant 1 or quadrant 2? Because the restriction says one of those.
Quadrant 2,
Why?
because it's negative, the cosine is negative.
Because cosine's negative. Quadrant 1, cosine's positive. Everything's positive. So you're in quadrant 2, so, Jonathan, you were concerned about it? My sketch this time's over here. I'm in quadrant 2. I'm gonna drop the perpendicular. I'm gonna form a right triangle, but I'm in quadrant 2. This is a visual of what? What eye? Form a small right triangle. And what do I know about the, right now at this point? I know the cosine's negative 1/3. Nima, please tell me. I know cosine on the unit circle, the definition is x. So if I place negative 1/3 right here, immediately, that's x. That's cosine. But that's only for a definition for the unit circle. So that means, professor, then you must be thinking of the blue as having a length of what? 1. Unit circle. I didn't draw the circle for you. I need to find the red, the vertical part. And I can use what, Pythagorean theorem maybe? And have 1 squared on the side here, guys. See if this will work. 1 squared is equal to negative 1/3 squared. Plus my missing side, we'll call it x, y, let's call it y. I need to find y squared. Figure out 1 is equal to 1/9 plus y squared, move that 1/9 over, you get 8/9. I'm just doing some of this math. Take the square root. Oh, a square root 8 is not nice. Does it break down? Like 2 radical 2, I think. Help me out. Over, thank goodness 9 is nice, 3. That goes here. And this is now a unit circle. I'm making sure that hypotenuse is the 1. So I should be able to read off directly. Now, what do they want for this angle? It's over in quadrant 2. And if you want to do this for the angle, just show it's over there. That's no problem. It's over there. And theta, right there. They want the tangent of it. Aiden, tangent, y over x. And on my sketch, y is this strange number. X is this strange number. And if I simplify that, I think the 3's canceled. I got a negative sign there hanging on. Look at this. There's the answer. Absolutely beautiful. Now, if you prefer,
Have you used the formula?
thank you. You say, Professor, I'm not too good about these visuals. I barely draw a triangle. I'm not going to go to the triangles. I don't like that. Well, option number 2. It says cosine is equal to negative 1/3. Now, I need some help though on this one. I'm going to do it another way. These markers will hold up. Cosine theta is equal to a negative 1/3. That was given to me. We're trying to find the tan and not touch a triangle. Anyone give me an identity? And I'll tell you ahead of time, it's not one that's directly related as we lucked out here. There was an identity directly related to these two. 1 plus tan squared is equal to secant squared. Can anyone give me at least something to work with that might lead me to where I would, oh, look at those hands going up, I love this. Love this. Rebecca,
Sine squared plus cosine squared is.
love it. Here we go. She said, Professor, start with this one. And Rebecca, they gave me cosine. She says, gave me cosine. So use that identity. Replace, absolutely replace cosine with negative 1/3. And you have this. Of course, it's being squared. Love this, love this. Equal to 1. If I finish this up, and not make a mistake here, guys, here it goes. Got sine squared. Of course, that's a 1/9. Square it, move it over. Guys, I think you're going to end up with 8/9. I'm just doing some arithmetic algebra there. 1/9, I subtract it. Take a square root. At this point, sine is equal to 2 radical 2 over 3. Sine is y. And thank goodness this y is positive. If you're equal to 2. So I'll accept positive 2 radical 2 over 3. Now, am I finished yet? I don't think I'm finished yet, am I? Did we finally get that answer? We got this answer. They were asking me, now find the tan of that. Now, can anyone tell me what might you do now with her answer to get a tangent because they want tangent? I think I heard it. Here we go. Is tan sine or cosine? So on the side here, you can say, Professor, go a little further. This is tan. Another identity, sine over cosine. Look at this. They want tangent, that's it. Sine, with Rebecca's help, gave me this. Cosine, what's given to me? Negative 1/3. 3's cancel. I think I end up with this. Please, is that the same answer I got way back here? And I did my triangles. Okay. We got a big chunk of work done tonight. We're not finished, of course. Now, please tell me at this point, when you finally see these Friday, you'll see this on the test on Friday, these types of problems. I'm gonna leave it up to you. Would you, let me see if I show of hands, how many students would prefer to visually draw a triangle to represent what's going on and find it by using a triangle? I see one hand. I see one barely. Oh, I guess the remaining class says, Professor, I prefer to do this. Use the identities. It's up to you. So at least you do the same answer. you guys sit back, Phil, go for it.
Are we gonna have like a question where we're gonna have to do one or the other? Like, would
Wait,
we
did we
this
get
way?
that?
Are we ever gonna have a question where we're gonna be required to do one or the other? Like with completing the square? Like, are we gonna have to?
Oh, beautiful, complete the square, or use quadratic formula, all that business way back when we first started.
No, I'm saying, are we gonna have to do like the same thing, or like, are we gonna have the thing where we have to draw the triangle?
It depends, well, when you move to math 7, I don't know whether that instructor is gonna ask you out, that's why I showed you both ways. I don't know whether that math 7 instructor will just allow you to do it any way, do it this way, or that way, or they may, we all have different personalities and ways of teaching, they may insist you use identities. That's what I'm sure you both. I am gonna leave it up to you. Yeah, I'll leave it up to you, that's how you approach it. Guys, good lesson tonight. I think we're feeling a little bit better about tree, aren't we? Yeah, I think we're feeling a little bit better about tree now with all this here. Caroline, it's not that hard. There's a lot of it in 6 weeks, but it's not that hard. Just gotta keep up with it. So you guys look at it closely, because we've got something for you to do here shortly. Anything you'd all ask about? On this? Yes, go for it.
This is actually like a much more fundamental question. The constraints of like the boundaries
Uh-huh.
for each function, sine, cosine, tangent, etc. We have to memorize.
You have to memorize.
We have to memorize.
I teach the word memorize in math, but you gotta memorize those.
That is, we memorize.
Got to.
Okay.
And therefore, when you go to USC or wherever you're going, if you take another math class or you're going into math, they don't change. So whatever math you do in grad school, whatever, you do more math, they do not change. So just go ahead and memorize them now. Inverse sine, inverse cosine, inverse tan. I'm not holding you responsible for inverse secant, inverse cosecant, inverse cotangent. It's those 3 basic ones. I like this, guys. I really like this, where now students have an option. Some students are very clever. I've taught many years, I know how students are. Some will, in their mind, quickly see this. They see this. Others will say, no, professor, I see this. I see the relationship like this with my identity. And both will lead you to the same answer. Okay? So that's the one part of this. Now, let's see what I have for you to do. Oh, yes, yes, yes. Okay. Do a little erasing here. Miriam, are you telling me I'm a little bit behind on my syllabus? We got a little behind, I think. I think we're about to catch up though. She's always watching that syllabus and homework assignments.
Yeah, you're a little behind.
A little behind then, still a little behind. Not quite to where it said we should be on the syllabus. Okay, but we'll get there. But I got something for you guys to do. I think it's a good way to do it. Mr. Park and Arena usually do a little extra credit for you guys. And by the way, those 4 points you saw when I returned your test to you, those 4 points were put in for you. Would that help if we brought in on Friday another, or have them do another extra credit, maybe 2 points this time? Or at least something. Would you guys appreciate that if we brought in maybe 2 points or 3 points for extra credit and bring it in like you did last Friday? And then I put into the grade. I don't see anything wrong with that. Class is a rigorous class. So we'll talk and we'll get something out to you to do that. But for right now, what I want you to do for me is get an input from you. Is this. I'm going to give you a few seconds to think about it. I'm not going to jump right into it and do it. And that is to solve an equation. And some students in my 2 o'clock session were asking, Professor, there's a section coming up where they ask you to do this. Solve the equation. Oh, good, we'll cross the street here, go to the middle school, solve some of those nice equations they have over there. No, mine here, they look a little different. First one. I like to solve this equation. Cosine of 2 cosine double theta is equal to 1. And I like to find this on this interval. This is what I'm sort of closing down class with. Guys, just relax, think about this. They want you to solve for theta. It says cosine 2 cosine double theta is equal to 1, solve for theta. Think about it. I'll get some input from you and go from there. Or maybe, when I say relax and look, maybe a student says, Professor, I think I see one just thinking. I think I might see an angle right now, 5 or 6, 5 or 4. I think I can see one right now. If you try it, it'll check. Does anyone have in mind just mere observation? Anyone think of one that may check? I'll check it. Anybody, you got one in mind? Oh, hang on. Tell the class, but I'm looking for every one that you can find here. Tell me one that you think will work.
5 over 6.
That's 30 degrees. So we'll check it right now. And ask you what you did to get that. Here goes, guys, check. 2 cosine. Double, he says pi over 6. Professor, that should give you a 1. Clean this up, this is 2 cosine. I can do a little canceling inside there. That becomes pi over 3. Now, you must recall, Philip, the x-coordinate, or cosine, at pi over 3. Do you recall what the cosine coordinate on the unit circle at pi over 3 was? It's 1/2. Nima, look at that. The checks. Pi over 6 is an answer. Is there another? Now keep in mind, they put a restriction on us. They want to find all those caught between 0 and 360, or 0 and 2 pi. He's giving me 30, 30 works. Is there another one?
Yes.
Like what?
Pi over 3.
Pi over 3?
Yeah.
Hang on. We'll check pi over 3. 2 cosine double pi over 3. Just give me a 1. 2 cosine inside there. Well, just 2 pi over 3, nothing cancels. Equals 1. Nima, I think on this one, when you check out the unit circle and find the x-coordinate or cosine at 2 pi over 3, I'm thinking to myself, is it negative 1/2? 2 pi over 3. Help me out, guys. 2 pi over 3. Is it on the unit circle negative 1/2? And I think in this case you would end up with the 2's canceling, but you end up with a negative 1. They won 1. I see why you said pi over 3. Close. Now the trouble is, I know what you're thinking. You're thinking, Professor, shouldn't we just get one answer? Philip, what did I not do on this problem to insist, or that you're restricted to one answer? Why am I not looking for more than one answer, maybe? Why are you not restricted to just one answer like we were doing before the break?
So you have more than, two quadrants.
I like that too, something else. Yes,
You can restrict the 0 to 5.
oh, I like that too, something else. What might alert you to right now that no, professor, you might have more than one answer, even though your, discussion before the break, you had just one answer. Ooh, something else easier than that. What up there tells me you're okay if you had more than one answer, but before the break, you had to have just one answer. Do it again. Nope, something else. Something else, John.
The 2 theta, you're gonna end up, the period's only gonna be pi, so it goes around because it's shrunk, but it's still within 2 pi. So everything will be like this much, and then that can repeat within.
You know
2
what,
pi.
almost
Something
every
like
answer
that.
I'm hearing, I accept. Except you guys have not given me the most simple thing that tells me up there. Professor, this one, you can have more than one answer. Before the break, we had only one answer. What is it? What alerts me to there could be more than one answer? Or alert me to, we don't, there's not just one answer. I see you hang one up, Michael.
The restrictions,
Oh, and now tell me more. What were those restrictions involving?
Like which different quadrants.
Thank you, tell me more.
Which different quadrants.
And what was the whole topic about? Where you have those restricted intervals, that was all about what topic discussion? And I spent all that time before the break. Inverses.
Wow.
Does anyone see an inverse notation up here? No. I don't see any inverse notation. They didn't restrict me. So they're saying find all the answers possible. So besides what Nima gave me 5 or 6, I checked if there might be, in fact I think there is. I think there's another answer. Or, well, it could be more than one. I know what you're saying. Farbod, you think you have another one?
It's got 4 answers, I think.
He said it's better. I think you're gonna have 4, 3 more.
Because 2
So you
theta-
certainly are not restricted like before the break with that inverse notation. Remember, if you see that inverse notation, there's no inverse notation on this problem. I'm not restricted. They want all that you can list. Caught between 0 and 2 pi. Farbod, you have another one in mind that maybe I can check, and then we'll go through and try to find a way to find them.
They
It's
should
not
give
5
you
or 3. I checked 5 or 3.
300 degrees is between 150.
150, 5 pi or 6?
Yeah.
Hang on.
I get 7 pi over 6.
Okay, I'm gonna check the first 5 pi or 6. Going back, this is 2 cosine, 2 times, he wants me to use 5 pi over 6. And I hope you get a 1. Inside there, you do a little canceling. So this is 2 cosine, 5 pi over 3. Hope you get a 1. 5 pi over 3 from that unit circle of my units, like 300 degrees. And they want cosine of that. Does anyone know what the cosine x coordinate at 5 pi over 3, which is like 300 degrees, was? 1/2, I think it's 1/2. Oh, look at that, you found another answer. Now I'm here, Professor, there's another one. There is? What'd you have in mind?
11, 5 over 6.
11 pi over 6, I'm trying. What a nice way to close out class tonight. We're gonna check it. One back. 2 cosine. 2 times. And we did, we're trying 11 pi over 6. And we're hoping all this will give me a 1, if I wrote all that down correctly, which I think I did. Inside here, that gives me that. It's 2 cosine, 11 pi over 3, which is getting messy, is equal to 1. Get through, guys? Now, 11 pi over 3 is a mess. Is 11 pi over 3 on the unit circle? What's on there? It's 11 pi over 3 on that unit circle. You're scaring me. It's not on the unit circle, is it? Well, it's this. Since it's not there, let me do this to see where it is. This is 3 pi, not 9, pi. This is 9 pi, the remainder of what, 2? And I could express it like that if I want to find it. So there's where 11 pi over 3 is located, if I did my math correctly, right? I think. Yeah. But it says to find it, you have to move 3 pi. That's one complete revolution. You have another, we did this one day in class, another revolution, a half a revolution. This now takes me to 3 pi. This is this. There we go, that's 3 pi. And then move from there an additional what, 120 degrees, which is 2 pi over 3. Is this angle finally going to stop somewhere in quadrant 3? That's true? Yes or no? Is that 11 pi over 3? Woo! Anyone tell me what 11 pi over 3 is in degrees? Convert it right quickly. 11 times 60. I think it's 11 times 60. What's 11 times 60? 660 degrees? That is just standing there, isn't it? Are we talking about a 660 degree angle? Oh, Nadia. 660 degrees? I know that's 360. And then I moved that additional, whatever that is there, what, additional 120? Oh my goodness, is that gonna work? Okay, here goes. I had you guys guess at some numbers. Nima, I checked a few.
To make it, I have an idea.
Go for it.
Okay, to make it easier, can
No,
we say that?
that's right.
Can we say that this angle can be 2 pi minus pi over 6? 2 pi and pi over 6. 11 pi over 6.
Hang on. This angle here can be represented like this. 2 pi subtract how much?
Pi over 6.
5 pi over 6?
Pi over 6.
Oh, 5 over 6. Now, he's being clever. Guys, is 2 pi subtract pi over 6, put those two together with a common denominator of 6. Is that the same as 11 pi over 6? Beautiful. Now what?
So, according to this, it's gonna be in the fourth quadrant, if I'm not mistaken. 2 pi.
Okay, 2 pi subtract pi over 6, you think it's gonna be an angle down in quadrant 4.
Yes.
Okay. So you're telling me if I do this, okay, I see what you're saying. You're saying that might be an easier way to come up with those angles.
Exactly.
Okay, why did I do this in class tonight? Jonathan, I had you guys first think about it. Look at this. Now watch carefully, I'm closing down. Let's solve this. I'm gonna actually solve this like those kids across the street. They across the street to close down tonight. Barbad, they see this across the street. And the teacher has them solve for X, and the teacher is happy, the students are happy, everybody's happy. Because they can solve 2x is equal to 1. But that's what in the black there, that's the form it takes. So I'm gonna divide by 2, I think our students say something about that 2 out front. Guys, first thing I'm gonna do, from middle school, divide by 2, and rewrite this like this. Just like the middle school kids do. This would be x is equal to 1/2. There, they were finished. They went home. They went home, told their parents, I solved 2x equal to 1. Everybody's happy. The parents take them out to lunch or dinner, whatever. Yeah, everybody's happy. did exactly what they do across there first. Now, here's what we're gonna do, close down. Can anyone tell me at least this much? Where on the unit circle, for sure, have you seen cosine, the x coordinate equal to 1/2? Pi, I heard, was it pi over 6? Or pi over 3? Cosine is equal to 1/2, the x coordinate. Is it pi over 3? It's not pi over 6, is it? Don't scare me now. That's just a beautiful night. Don't scare me. Okay, pi over 3. So you're telling me that this right here, this argument, could be representing pi over 3. Is that true? And some students may say, Professor, if you make one complete revolution and go back to it, that would also work. It repeats with a period of 2 pi. So you could say just add 2 pi to this any number of times you wish. I think your textbook uses a K. I can't remember where n is an element of the integers, and that will pick up all of them. And then you'll decide which ones you want to fit inside that interval they gave you. Trouble is, there's another angle, I think, on the unit circle where cosine is equal to 1/2, besides pi over 3. What is it? What other angle have you seen on the unit circle where the x coordinate cosine is 1/2?
Minus.
Is it 5 pi over 3 directly on the unit circle? Yes or no?
Yes.
5 pi over 3? That means, oh, you got another possibility here. 5 pi over 3, and you make it repeat by using the period number. And n is an element of the integers. And you have another one to consider. I'm closing down this. Now, then what you solve for theta. That means if I want to finish up, I'm not quite finished here on this 80. I know it's difficult for you to see, but I'm going to divide by 2 to finish this up. Look at this. They want theta. 2's cancel. Theta's going to be equal to, guys, if you finish this up, this is pi over 6. Look at this. That's this much right here. That's pi over 6. And on the end, can you tell me what the end, the last term would be? Because I also need to divide 2 pi n by 2. Will the 2's cancel? And leave you merely what? Pi n. N is an element of the integers. Now that in the blue will name every angle out there that would, that would satisfy this equation. Every one. We don't need all of them. We'll come back to it. Another possibility. We'll divide by 2. There are 2 angles possible here. These cancel, of course. You get theta. This much right here is 5 pi over 6. Can you clean up? The other part, this part, 2's cancel, leaves me for the n part, what is it, pi n? Which n is an element of the integers. There's another, they call these general solutions. Navia, this one and this one name all angles that will satisfy this equation back here. They didn't want all of them, Farbod. They asked me just to list the ones here and here. And you guys were guessing and naming something for me. They're saying, no, you don't need all of them, Professor. That would name all of them. You just need the ones between 0 and 360, between 0 and 2 pi. But what I can do now is, let's get this first one here. Let me check my time. Yeah, I had to stop this. Okay, pi over 6 plus pi n. N is an element of the integers. I do it this way. I start replacing n by integers. That's what it says I do, replace n by an integer. I usually have to start with 0. If I replace n by 0, guys, what is a possibility for an answer? Pi over 6. This term will drop out. And I think, Neva, you gave me pi over 6. Someone gave me a pi over 6, didn't you? Where was it? Did someone give me a pi over 6? And we checked it, didn't we? It worked, didn't it? Am I on the same problem? Another possibility would be, okay, I replace n by 0. Let's say let n be 0, so you know where that came from. Say that came out to be pi over 6. Now we'll try this, guys. Let n be 1. That's an issue. If I let n be 1 up here, this becomes pi. So what's pi plus pi over 6? Common denominator of 6? 7 pi over 6? By the way, make sure they're still fall here. And just want the ones that fall here. By the way, guys, would 7 pi over 6 fall within that restricted interval they gave you between 0 and 2 pi? If I try 2, I mean, there's lots of integers out there, even negatives. So I put a 2 in here, I get 2 pi. So that would be 2 pi plus pi over 6. I'm doing the math in my head, I think it's 13 pi over 6. What's wrong with accepting that? Even though it works. Yeah, outside this. And we'll just one's listed here. So I've got 2 answers that I will accept at this point. Now I know we're running out of time. What am I supposed to do also? Before I leave it, are there more answers? I think, Barbara told me early on that he thought there was supposed to be 4. I've got 2. Where might the other 2 come from? I have not done, I haven't done this one yet. I went 2 equations. I just looked at this equation, I think right here, pi over 6, I did. Let n be 0, n be 1, and you're supposed to do the same thing down here. Now I think you're gonna pick up 2 more and get 4 altogether. Is it true? And you'll get 4 answers. Now that sort of sets me up for tomorrow. Tomorrow's Tuesday, right? We don't have a quiz, do we? No, okay. So that sort of sets me up for tomorrow. Woo! Finally, I see some looks on faces like, I think some of this is coming together now. It's a lot, Professor, because it's so fast. Guys, in the regular semester, it takes me a good, what was it, chapter 5. That was chapter 6. Chapter 6 takes me maybe 2 weeks. 2 weeks. And we're supposed to do it in 2 days. Which we're going to get very close to closing it down pretty soon. Guys, make sense? Now tomorrow, here we go. I will bring, you have a copy though. I'll have Mr. Park to make copies of the unit circle for us.